Thank you so much, James. And thanks a lot for Glenn and Eric to invite me. And it has been an absolute joy to participate in this conference. So this paper is called One Man, One Bit. And this is a theory-driven experimental work. But after we completed this paper, we realized that Glenn has already written 40 pages of a much more generalized theory. So that's not good news for us, so no more top 5 journals. But on the other hand, we are also very happy to see that great people are working on the same topic. So we hope that there would be very fruitful collaborations in the future. And so both Jakob and I, we were in University of Zurich when we first started this project. So I think for this audience, I don't need to convince you why it's important to study alternative mechanisms that can improve on voting. And for me, the idea came about because when I moved to Zurich in 2010, like one of the most cultural shock I got is that how often Swiss people vote on about everything, right? So they vote on the, how much vacation an employee should have. They vote on whether the shops should be closed on Sunday, etc. So to me, for example, when Swiss people voted down the shops closing time, so basically shops cannot be open on Sunday, it affects the shop owners and also a selective group of shoppers like me, right? So I really hope that I can go shopping on Sunday because I work so hard during the weekend, during the weekdays. And also, typically in those referenda, some people gain while others lose from the outcome, and typically some people care more while others may not care that much. And that's why it's important to look at whether majority voting or simple referenda would result in socially optimal outcome when people do not only differ on which outcome they prefer, but also the intensity of their preference. And in particular, in this paper, we look at cases when there's no ex ante winner. That means ex ante, both alternatives are equally likely to be favored. Okay? So in some sense, we think this is the only interesting case, because if ex ante, it's very clear one alternative has the highest expected payoff or expected value, then you should simply command that outcome to be implemented, right? And there are many ways to do that. So that's why we choose to look at this special case when there is no ex ante winner. And just to give you a graphical example, so we think in this case, voting is actually an information aggregation tool. Why? Because suppose voters are equally likely to favor or oppose a proposal, and when voters' preferences are homogeneous, and this is like a realized draw of their values, then you simply count how many red balls and how many blue balls are there. And clearly here, red balls are more than blue balls, so you should implement the outcome that red voters prefer, right? But when there are heterogeneous preferences, then it is this example. Although there are more red balls, but the total sum of values that blue balls have are higher. So in this case, you should implement the proposal that is preferred by the blue guys. Okay? And also another disadvantage of majority voting is that there's no compensation for those that lose, right? So in the case of, say, rezoning policy change, then it would be rather cruel if you don't compensate those people who now have to suffer from the rezoning policy, right? Maybe because of the rezoning, they cannot send kids to good public schools. Maybe the house value would drop for them, so things like that. So that's why we propose a bidding mechanism. And before that, we first actually document that voting is an inadequate information aggregation tool. And we study it in the case of when there is no ex ante winner. And we show that the fraction of surplus realized falls in the size of electorate. Okay? and the total surplus loss diverges in the limit. And again, as I mentioned, there is the tyranny of the majority problem because there's no redistribution from people who benefit to the people who suffer from the outcome. And the simple bidding mechanism we propose goes like this. So voters can buy votes at a quadratic cost, and at the same time they receive a rebate, which is the average payment from other voters. Okay, so we prove that this is a budget-balanced, individually rational, and fully efficient mechanism in the limit. Okay, so it's a limit result. And because of the rebate mechanism, there's automatic redistribution from the winner to the loser. And everyone is better off than undervoting in our setup, in our model. Okay, and the main messages from the experiments is that we use a 2-point value distribution, so there are only moderates versus extremists, and they choose between ex-ante equally strong alternatives A or B. And the main findings are that bidding is more frequently selected as the preferred mechanism. So it's a two-part design. So in the first part, voters can make decisions under both mechanisms. At the beginning of the second part, we ask them collectively to decide which mechanisms they want to use. And I will talk about it in great detail later. So basically, we find bidding is much more frequently selected as a collective decision by the electorate. And also, bidding is significantly and substantially more efficient than voting. In the experiment, moderates benefit more than extremists from bidding, and we use a QRE model which assumes that voters overestimated the chance of being pivotal to capture the data. Okay, so this is the main message. So let me quickly go through the theory. So the environment we look at, the voting environment, is that there are 2n plus 1 voters. Voters vote for one of the two alternatives, A or B. So for the presentation, I will just go through an example with standard normal distribution because it allows us to compute the predicted efficiency exactly for any electorate size. But for the theory per se, it actually can be generalized for any symmetric distribution. And in the setup, if you draw a negative value, it corresponds to a preference for alternative A, and if it's a positive value, then it corresponds to a preference for alternative B. And the alternative with most votes is going to be implemented. The voter receives an absolute value of V if outcome matches their preferred alternative, and otherwise they receive the negative of this amount. So, of course, it is a dominant strategy to vote for preferred alternative in this voting environment. So let's calculate the ex-ante expected welfare under the majority voting, which follows this formula. And it's actually quite easy to understand because the intuition goes like this. If you try to summarize all possible events based on vote lead, then those are the possible events. And all the blue numbers means that the vote lead is plus 2k, so the blue guys already wins. And for the negative red numbers, it means the red guys wins. Okay? So because the vote lead with plus 2k and minus 2k for k is greater than 0, it's equally likely. So when you sum it up, they cancel out. And then the only pivotal event is when k equals to 0. So that is, except you, there are exactly half of the others prefer the same alternative. Okay, so that's the only remaining case. And the probability of this event occurs is this. And then the expected value on the standard normal value distribution is this square root of 2 over pi. And there are 2n plus 1 such voter. So that's how we get the ex-ante expected welfare under majority voting. Now to calculate the efficiency under voting or the fraction of realized surplus, let's see what is the ex-ante expected welfare under optimal mechanism, right? So now it's not the case that you count the heads, how many are for A, how many are for B. So this is the case when you have to sum up the values, right? So again, the intuition is simple. So suppose you are a guy who prefers alternative B, you draw a positive V, the positive value. Then alternative B would be implemented if a voter's value V and the sum of others' values is greater than minus V, right? And then you can figure out the probability on the normal distribution, which is this, and the voter would receive V. And with complementary probability, the voter receives negative V. And there are 2n plus 1 such voter. So that's how you calculate the ex-ante expected welfare under the optimal mechanism. So now the measure we use to see the efficiency is the fraction of surplus realized. That's the ratio between W voting and W optimal. And in the graph, I just draw the predictions on the standard normal distribution for this fraction of surplus. So for any electorate size. So when there's only one voter, of course, it's 100% efficient. But as you increase the electorate size, so the circle is the predicted efficiency on the voting, then it actually drops, okay? And it will falls quickly, and it limits to this square root of 2 over pi, which is strictly less than 1. So that's why the total surplus loss diverges in the limit. That's how we actually document that voting is an inefficient tool. Okay, so now if you generalize it to any symmetric value distribution, the result holds. Okay, so that's voting. How about bidding? So in our proposed bidding mechanism, voters can bid for either alternative A or B. Outcome with the largest total bid amounts is going to be implemented. Voter receives absolute V if outcome matches their preferred alternative, otherwise the negative of that amount. So irrespective of the outcome, voter who bids B would pay this quadratic cost function. And also, voters receive a rebate equal to the average of others' payments. So note this is the average of others' payments, so the rebate does not depend on your own bid. Okay? So why is this an efficient mechanism? So to actually, our view is that first, this is actually a limit result of the AGV mechanism. So if you take the limit of AGV payment, it would equal to the quadratic payment. Okay? So intuitively, in a large electorate, in a large election, the impact of one's bid on the probability that his preferred outcome would be selected is rather small, right? So approximately linear in the bid. So it means the marginal value of raising one's bid is proportional to its value, right? And now with the quadratic payment function, it means the marginal cost is linear in bid. So by equaling the marginal benefit and cost yields the optimal bid, which is proportional to the value. So that's why when the outcome that receives the largest total bid is implemented, it is also efficient. It maximizes the value, the total value. So that's the intuition. So that is our second proposition. So the bidding mechanism is budget balanced because of the transfer we implement, and it's individually rational. For large electorates, truthful bidding constitutes a Bayes-Nash equilibrium. And furthermore, voters of almost all types are better off on the bidding compared to voting. All right, now it's the exciting part, the experiment. So whether this positive result will hold in our experiment. So in the experiment, we choose a very simple 2-point value distribution, right? So voters are equally likely to prefer A or B, and the voters would be moderates with a value of 10 with probability of 0.75, and they would be an extremists with value of 70 with probability of P is 0.25. So why do we choose this 2-point value distribution? There are several reasons. The first is that we need to find a very simple environment for subjects to understand. Okay? We give them ample opportunity to understand and to be able to make actions or decisions that's close to the equilibrium. The second reason is that we need to pick the value distribution so that there is a big separation between the voting and bidding mechanism. And the third reason is that it is also easier for us to study the transfer with this 2-point value distribution. And also, later on, we use QRE estimate on the individual bid data. So with this simple value distribution, it's much easier for us to do that. Okay? And another deviation from the theoretical setup is that we actually use a strategy space that's between 0 and 10. So the bidders can make bids, integer bids, between 0 and 10. And I would actually tell you in detail why this, by limiting the bids to 10, will not actually affect our theoretical theoretical result, because actually the equilibrium bid, the predicted bid would be 7. Okay, so it's within this strategy space. And also the reason why we have this boundary on 10 is because it avoids very costly mistakes, right? So we don't want the subjects to bid a huge number and they have to pay a huge amount. They would go bankruptcy. So there's no way that we can ask subjects to pay out of his pocket to experimenter, right? We cannot run experiments like that. So that's why we set up this strategy space limit to 10. So with this value distribution, when the electorate size is 11, then the predicted voting efficiency is 71%, which is very close to the limit efficiency, which is 69%. Okay? So, and this is good news for us, because to run a voting experiment in the lab, we have both the physical constraints. You cannot have many subjects in the lab, right? And also because of the financial constraints. But with this distribution, and when the group size is 11, we already get the predicted efficiency quite close to the limit result. And also, if you recall, the fraction of realized surplus on the voting actually falls as the electorate size grows, right? So by having this 71%, it actually gives voting a better boundary, right? Than in the case when there are many people in the electorate. We are interested in the group size effect. So that's why we pick another treatment where the electorate size is only 3. And it's also because with 3, the predicted voting efficiency is 78%. So it is we have a relatively large distinction or large separation between those two group size. Okay? And with this setup, bidding is 100% efficient for all electorates. So the treatments, first, as I mentioned, it is a 2-part design. So the participants, the subjects participated in 20 periods for both parts. So in part 1, they decided under both bidding and voting mechanism. And for each period, actually, it's, we randomize the order, whether the voting shows up on the left side or the bidding shows up on the left side. Okay? And then at the beginning of the second part, we ask them to decide. So via majority voting to decide which mechanism they want to implement. We think by doing this, it offers perhaps the most clear evidence of voters' preference for the mechanism. And we use the fixed group, so there are 10 groups in each treatment. And we have 3 treatments. So let's look at the 11L treatment, where the letter indicates the cost variable. Okay, so in this case, the cost function, according to our theory, where the limit result applies, should be b squared over 3. Okay, and the optimal bits is proportional to the values 1, 7. So note we actually scale up the cost function so that the optimal bits is proportional to value, not equal to value. Okay, just to make sure the optimal bits are within our strategy space. Now, for the 3H treatment, so because when you increase the group size from 3 to 11, you roughly halve the chance of being pivotal, right? So that's why we increase the cost function by 2 times relatively to the 11 group size. And in that case, the optimal bits is 1,5. So note the 3H case does not follow the limit theorem result. Okay, so but you can calculate the optimal bits for this small group size. And we also have a second, the medium treatment, which we call 11H. So why do we have that? Because we realized from previous literature, subjects tend to overestimate the chance of being pivotal, right? So if subjects do not understand the relationship between cost function and the chance of being pivotal, then we can see it from the comparison between 11H and 11L, where in 11H, the cost function remains the same as the small group size. Okay, so that's why we have this. And for 11H, the optimal bits is 1,5. So to summarize, the prediction is that when the voting cost is high, for the extremists, they should bid 5. And when the voting cost is low, for the extremists, they should bid 7. Okay? For moderates, they always bid 1. All right? So we ran these experiments with 250 subjects from University of Zurich and ETH, and on average, people earned 43 Swiss francs. So I forgot to mention, the experimental tokens, to be converted to Swiss francs, we use 30 tokens equals to 1 franc for the group size of 11. Yeah, but as you can see, we have evidence to show the payment is salient enough because there are very few mistakes. All right, so this is the screenshot for part 1, where subjects are asked to make decisions under both the bidding mechanism, buying tokens, we call it, and the voting mechanism. So for the buying token mechanism, we do remind them of the payment functions, and we provide the calculator on the right side. So the calculator basically tells you, given the number of tokens you buy, how much you need to pay, and the earnings if your team wins, and the earnings if your team loses. And we remind them that there's a rebate, which equals to the average of 10 other payments. Okay? And for the voting, it's simple. It's either A or B. So basically, in the beginning of each round, subjects are told, OK, you are assigned with team B. That's your preferred team. That's your team. And your prize value, or your value that your team wins, is 70. So this is a case when the guy is an extremist. Okay? And now the results for part 1. So then we told them, OK, there were 7 people in team A and 4 people in team B in this example, and you are in team A. So on the voting, your team wins because there are more people in your team. But under the buying tokens or the bidding mechanism, actually team B wins because team B bought 18 tokens and your team only bought 8. Okay? And then we pay them the sum of earnings from both mechanisms, we also show the cumulative profit. All right? So this is part 1. Okay. So hypothesis, I don't have time to go through it, but so basically one thing I want to point out is that we look at the bid ratio, which is the extremist bid divided by moderate bid. So we derive hypothesis 4 based on the base Nash equilibrium, which says that the bid ratio should be the same for the high-cost treatment and higher in the low-cost treatment. But if we use another behavioral hypothesis, which says people don't understand the triviality of their bids, then you should find the bid ratio to be the same in all treatments. Okay? Okay, results. So for part 1, here I just plot the group level efficiency data for the last 10 periods of part 1. Okay? And so the horizontal is the predicted voting efficiency. So if the dots are aligned with the diagonal line, that means the observed efficiency equals the voting, the predicted voting efficiency. If it's above, it means the group did better than voting. Okay? So as you can see from those 3 treatments, the orange circle is the observed voting efficiency. So there are very few mistakes. Basically, there are only like 2% of people who bid against their team. Okay? And then you can already see with bidding, the efficiency realized is much higher. Okay, so that's result 1. Oh, and then the result 1 is about collective choice for the mechanism. Remember, we asked them to choose which mechanism to be implemented in the second part. Okay? So what we find is that the bidding mechanism is selected more frequently for part 2 of the experiment, in particular with electorates of size 11, 18 out of 20 groups chose bidding, and with an electorate size of 3, 4 out of 10 choose bidding. So we also asked them to provide a written explanation of their decision, right? Why did they choose one mechanism over the other? So those are some examples. So people understand that they can have more influence on the bidding. So they say with voting, chance decides. Buying tokens is actually a way to keep control for the fate. They also are happy, subjects were happy about the higher payoffs they are able to receive under the bidding. And they also mentioned that the extra rebate means a lot to them. Okay? So now part 2. So part 2, again, if you look at the group level, now, so there are only one group for each of the 2 treatments that chose voting. That's why we only have one circle. And all the other groups chose bidding. And there are like 6 chose voting here. And then you can see bidding is much more efficient than voting. And if we aggregate across groups, then this is the data. And clearly, bidding is significantly and substantially more efficient than voting. Okay? So to glean some intuition, why bidding does a much better job than voting, we look at 2 cases, right? So first is the easy case, when the median and the mean value of the voters are on the same side. So in this case, voting always gives you 100% efficiency, and bidding does a fairly good job too, so it's like 90, always over 90%. So the hard case is when the median and the mean value of the distribution is on opposite side. In this case, bidding does a fairly good job, so it's like 55, not that great, 55%, 42%, 54%. But remember, with the voting mechanism, actually the predicted efficiency would be negative 100%. So that's why bidding improves significantly in this case. Okay? Okay, we also care about who benefits from the mechanism. So the theory predicts that all types would benefit from bidding. So the data plot the per capita earnings. So the first 2 bars are the prediction the vote prediction and bid data for all treatments by the type, moderates and extremists. So with our setup, you can see, so under bidding, people under bidding, people are predicted to earn more than under the voting. And the green one is the data. So what do we observe here? Moderates are better off under bidding in all treatments. Extremists are better off under bidding in groups of size 3, so that's here, but not in groups of size 11. Okay, so there is some noise. So why, to understand this, why extremists are not better off in the experiment? Then we look at the bid ratio. So we can see moderates bid the same in treatments with high cost, and they bid higher in treatment with low cost. And the same is true for extremists. That's why we observe the bid ratio is the same in the high cost treatments, but lower in the low cost treatments. So when there's the treatments with high cost, then the theoretical prediction for the extremists is 5, to bid 5. And then when it's low cost, the prediction is to bid 7. Yeah. Okay? For moderates, they should always bid 1. So if you look at the data for the moderates with the high cost treatment, they bid roughly the same, but with low cost treatment, they bid significantly higher, even though the prediction is that they should also bid 1. And then for extremists, so it should be 5 for those two cases, and it should be 7. So extremists bid lower than the prediction. That's why extremists actually are not better off on the bidding with the large group size. Okay? So to capture the noise, we also did the QRE model, which assumes that voters overestimate the chance of being pivotal. And the test says there's no significant difference between the model and the data. Okay. So just to conclude, okay? So we have this simple bidding mechanism, and we have shown that it improves significantly over voting, both in theory and in experiment. And the mechanism is simple enough that we can actually implement in the lab, and we can find the positive effect. Okay? So I'll leave this here since I'm going out of time.
Yeah, that's right. You should describe Swiss francs.
But I answered some questions, so right. Maybe they should pay me, then I pay you.
That's right.
Yeah.
Just two quick questions. One is, how did the groups select which mechanism to use?
By majority voting.
Okay.
Yeah.
By QV.
No, because we cannot ask them to choose by QV because they don't know the value, right? Yeah, so we have to use majority. We don't use supermajority or unanimity. We use majority.
Is that sort of part of the experiment, or is it just like you just were curious and to find out what people liked? I guess why not just ask them which system they have each person do both systems and ask them which system they like better.
I mean, it's a design choice. Of course, we can do that, but we also know in the experiment, if you just simply ask them, it's not salient enough.
Right, so I see. So the idea is that they think they'll make more money.
Yeah.
Okay, and then the second one is, in one of your slides, you show there's a lot more. It's really interesting the way the majority, for regular voting, it just falls along that line pretty consistently.
Yeah.
Whereas for the bidding mechanism, it's all over the place. The dots are sort of.
I think I was referring to the earlier slide.
Yeah, that's that's the slide.
Oh, that's the slide?
There's an earlier one.
Yeah, there's an earlier one also.
There's an earlier one where a lot of the blue dots are below.
Right. And what exactly? I mean, is that because people are making more mistakes? Is that so? There is. I mean, the thing about the bidding one is it is much more cognitive challenging for people, right? I mean, that is a key thing to take away from this experiment. Whereas the nice thing about voting is that people understand that quite well.
Right. Yeah. But so if you look at part 2, you can already see it's not as.
I'm more interested in the variance rather than the efficiency.
Yeah, but the variance it's because it's based on the value draw, right? The realized value draw. So sometimes the value draw is rather like all over the place. Then it's difficult for them
What is
But is this higher variance relative to that draw? So let's say you kind of put up a structured null, right, that reflected essentially the most efficient spread in the voting
Okay.
case. Then is this higher variance relative to that null versus the
Yeah,
voting
okay,
case?
I got it. Yeah, sorry, we haven't looked at it, but that would be interesting.
But JingJing, it has to be because you have some numbers dipping below the line. It has to, because the theoretical prediction is
question is how
100%
much?
efficiency.
Yeah,
Yeah.
right.
What is a blue dot
Blue dot is the observed bidding efficiency on the group level
at the group level, meaning over all the rounds?
over all 20 periods in the second part. Average.
So this is the average
Yeah.
for the group.
For the group.
20 times.
Yeah. I mean, of course, I mean, groups, I mean, it may happen that that group people are not as sophisticated as the other group, right? So that, yeah, there's the noise that we cannot really control. Yeah.
JingJing, I had two questions sort of related to the theory. The first one is, you motivated the focus on the zero mean case by the case that that's the only one where things are non-trivial ex ante. But if there was aggregate uncertainty ex ante about what the distribution was,
Yeah,
then
you're
it would
right.
be uncertain as well.
Yeah.
And that seems like I mean, to me that's a much better motivated case because the chance that something is literally on the knife edge at zero,
Yeah.
that just seems like a very concocted example.
Yeah, you are right. I should be more clear because we focus on the symmetric distribution, right? But you are right. If you focus on aggregate uncertainty when there's asymmetric distribution, then you are right. So
It's not asymmetric. It's just that there's uncertainty over what the distribution is. But
right. So you don't know how many would turn out to be in favor. Yeah.
So the second thing is that you claimed that the bidding was fully efficient in finite populations, which I guess that's true if you assume people are reporting truthfully. But given that they only have an incentive to report truthfully in the asymptotic limit, the actual equilibrium in the finite population is not fully efficient. Have you done the calculation at an actual equilibrium of how much efficiency you expect?
So with our experimental setup, actually, even though they are not bidding at their value, we are still able to reach 97% with our parameters here.
Okay, so it's not 100%. It's
No, for 11H, so for the high cost treatment with group of 11. With the other treatments, it's 100%. But we chose the parameters, right? We chose the parameters so that it's close enough to the theory. That's the beauty of running experiments.
I agree. I've run many examples, and you never get more than about 5% deviation, but you don't get 100%.
No, we don't. Yeah, we don't. That's right.
So I have questions that are almost the same as Glenn's questions, which is, when I was reading the paper, it was disorienting to see you prove in 2 pages something that Lely, Weil, and massive appendices are not proving, and you're proving much stronger. You're proving Pareto results as well, which I think even with the mean equals 0 case.
I mean, I can explain the difference to you.
Yes, but in any case, sort of as this
very
goes forward
different.
and when it gets published to the volume, it would be sort of helpful to have some mutual reconciliation. And on the experiment, sort of relating a lot to Glenn's questions, I would like to see for the parameters we set up, what is the equilibrium? And what would the equilibrium be if we didn't combine people to integers, and how does combining people to integers change that?
Yes.
Another thing I would like to see is for the actual results, like people going to, especially since you have people doing 20 rounds and then 20 more rounds, so you have a lot of learning. Sort of, looking at the latter rounds, and you already have the data, you don't have to redo everything. I would like to know not just how those bids compare to the predicted equilibrium, but I'd say, given how people were actually playing and what people were doing, which they've now observed, and they've had different draws themselves, so they've experienced this, what would be the QV rational thing for me to do, given what I've seen how other people are playing?
Yeah.
And how does what people do compare? And you have all the information to present that. So coming up with some nice way to present that, I think would just give us more insight.
And the overtime convergence as well.
Yeah. Yes, to see whether in the last 10 rounds, are people getting more to the predicted equilibrium? Are they adjusting to what others have done before? Is it, but you have enough rounds and you have all this data.
You are right. We can look things more in detail. I mean, we did look at the aggregate data. So if we just take the average bid by the moderates, say 1.61 here, and they use the average bid for the extremists 4.3, even though it's not as extreme as the theory predicted, still it's sufficient enough to have a much
Part of what
higher.
I'm saying is, if other people are doing things other than what theory predicted,
Yeah,
then what
yeah,
they should be doing is different.
That's right.
And one would like to see what kind of learning and processing. And you know, we're doing it in the small end, but and it may not be statistics, but you've got 10 periods, the later periods.
Yeah.
You know, one can really, I think, enrich a lot when one extracts from this
Yeah,
by looking at
thank
those
you.
things.
Yeah, thank you. That's a good suggestion.
I'm curious, back to Eric's question about cognitive complexity. That's right. So one thing is obviously the variance relative to actually the expected variance, right, given the draws. But second is just, time complexity. Like are they pushing the timer, at the same rate? Do they complete? I don't know what I don't know how you set up the time in the system. So either heuristically or precisely, like how much more time does it take? And you've got all these quotes,
Yeah.
like is there existential confusion? Are they like, is this a pain in the butt? Are they tired? I mean, what?
Right. So we do look at the mistakes, not relatively to the amount they bid, but whether they bid for their preferred alternative or not. Then the mistakes is only like 0.7% in the second part. And we do have data. So we programmed in Z-tree where we can see how long it takes them to press the button to continue, right? So we can analyze that. We haven't done that. But we actually give them, we did not set a time limit. So there would be a warning in red letters saying, okay, please make a decision. That's it. But they can still take as much time as they want. Yeah. But you're right, we can look at the time.
But what about quotes? So you've got all these quotes about how, I prefer, did people express, exhaustion?
No, not really. They find it's quite exciting, and also because
That's the same thing.
I need to look more into this, but like my impression is that people really enjoyed being in this experiment, and there are things that about free riding behavior that people commented on, because with group of 3, when the extremists free ride by bidding 0, it has a big impact and people are not happy about it. That's why with the small group size, so there were only 4 groups voted for bidding, right? So we do find those comments, but I don't recall whether people were saying it's too tiring or, yeah.
I think your comments that you're getting from people are some of the most interesting things, because I was predicting I thought this was going to be easy, that they were just going to say the money talks thing, which one of the people said.
Right.
But you're getting people saying they have more of a sense of control. So in
A cognitive bias as opposed to something.
well,
that
no, there are
corresponds to
process benefits here. That people feel like they're more in control of destiny with quadratic voting, which is a potential benefit of quadratic voting that's going to be missing from the simple models.
Right.
I mean, that could be partly an expression of I'm getting higher welfare, but I think it's quite possible that sense of control is a distinct process benefit as well.
Right, absolutely. So actually, my dissertation is on chip talk communication, and I actually used a very rigorous content analysis of the group communication in other environments. But the problem I face is that when I submit it to journals, I mean, maybe it's just bad luck, referees do not really appreciate the content analysis I do on the group communication.
That's changing.
That's changing?
I mean, that's changing because of machine learning.
Okay.
Because of the dominance of machine learning, people are starting to accept that stuff. So.
Okay, that's good to know. But I mean, it would be nice if people appreciate more of this type of analysis. And of course, we have the data, so we can do a much more rigorous analysis on content.
Well, but the other thing that I think would be a standard thing to do is once you have something identified in the free response, you might as well single it out and ask specifically about it. What's your sense of control in this option and in that option?
You mean after the experiment is over?
Because basically, the next time you run an experiment like this, I mean, even if it's a slightly different experiment, and the virtue of that is you're only getting information on sense of control for the few people who spontaneously say it, but it may well be that everybody's feeling more of a sense of control that
Yeah.
just didn't occur to them to say.
You're right. I mean, one thing is that we could not do that in the middle of the experiment because by asking them, we may bias their choices
Oh, you can
at
do
the
it
end.
after it's
But
all
we
over.
can do it afterwards, and then, yeah, we can certainly get a feeling of how people think along this line. Yeah.
I don't think it's just process. I think people realize that if the outcome matters to them more than it matters to other people, they have a mechanism of influencing the outcome, and they consider that a good
Well,
thing.
that'd be nice to distinguish.
Yeah.
No, if there is a way to identify whether people value sense of control over and above the fact that they're getting more money in the end.
Yeah.
And it's not immediately obvious how to do
Right.
that, but I think that's an important question.
You're right. Yeah, you're right. I mean, for that comparison, I can already do with this data set. So, yeah.
Yeah, just as a matter of the information that you're reporting, I thought it was interesting that some groups in some periods are bidding too much, and other groups in other periods are bidding too little, and so it doesn't look like there's any sort of dominant bias that people will overbid or underbid, value, the upfront cost more than the eventual payoff. It might be interesting if you could report sort of what those actual bids are, or at least a frequency distribution of actual bids, to see if they're clustering around certain focal points, or if people are sort of subject to certain heuristics when they're picking.
Okay.
Everyone's always bidding one, or lots of people are picking 0 or 1.
Yeah, that's right. I should definitely check number 8 because that's the lucky number for Chinese participants. You're right.
JingJing, just to get back to Lewis's question, given that I've got you here, I've been trying to understand for several years exactly what you guys are claiming to have proved in the general theory section. Could you articulate that? Like, what is the claim that you've proved in the asymptotic limit as the population gets large?
Yeah, so, okay, let me go back to,
Okay, so you say bidding mechanism, budget balance, and individually rational for large, truthful bidding constitutes a Nash equilibrium. But
yes,
what do you mean by truthful bidding constitutes a Nash equilibrium? We know that's not true. I mean, it's not true that it constitutes a Nash equilibrium. It might be an epsilon Nash equilibrium for large electorates, but it's not a Nash equilibrium. I mean, you can calculate the exact optimal strategy.
it's not a dominant strategy, right?
No,
So
but it's not a Nash. I mean, I've computed the equilibrium in this case. It's definitely not true that the Nash equilibrium is truthful. It's approximately truth. Like,
yeah, okay,
So-
okay, yeah. So,
there's just a lot of claims in the paper that, like, I don't disagree with what you're saying, but I don't think the actual statements in the paper are true. Like, in other words, like, there's a formal meaning to those statements,
yeah,
and they're not, and I don't think that's formally correct.
okay.
So,
I have to double check with Jakob, who is the theorist on this paper. Yeah, but like my understanding is because we choose this particular fraction in front of b squared, right? Which gives you,
It's approximately.
yeah, by Taylor, yeah, it's,
But it's not literally
Taylor
an
expansion.
equilibrium. Yeah.
yeah.
But I also don't understand the last sentence. And I didn't, we have to, so you say it's Pareto optimal for almost everyone in the limit. And, we saw presentations yesterday with clear redistribution going on. And so I don't know what you've assumed about the nature of the distribution and everything else that could possibly yield the Pareto result.
That's definitely false. I mean, in fact,
I mean,
you know that extreme types who are on the losing side.
Yeah,
Also,
exactly.
Yeah, I mean,
Exactly.
just
And
can't-
if I'm
they can't be
completely
true.
indifferent,
But another
I
example-
do nothing and I collect money, so I'm better off. That's coming out of someone else's pocket.
It can't
If
be
we could posit the case that's perfectly symmetric and close to a tie, so total efficiency is about 0. We know all the people near 0 are gaining, so we know the extremists are
There's an even
losing.
easier.
Yeah.
What you could do is, you just add a positive mass of voters who are indifferent.
No, but something's been assumed here about the distribution.
Something's been assumed.
No,
Subject to this assumption.
So there's a bunch
But there's no explicit assumption in the paper as far as I know. I also don't understand what W sub bidding means. Does that mean the Bayes-Nash equilibrium of the bidding mechanism? Or does that mean if everyone bids truthfully, that is correct? Whereas the Bayes-Nash equilibrium we know does not involve truthful bidding. So there's also issues about when you say epsilon approximate Nash equilibrium, like do you mean in proportional terms or do you mean in There's a lot of questions about what this means exactly.
Okay, I need to write them down and then go back and report.
Anyway, I guess the overall comment is
Both sides
just
are spending.
you should be. I would be very clear about the assumptions that are being made, because there are things in the paper which, if interpreted very literally and formally,
Okay.
I know are false. Like I have proofs that they're false. So you don't want to
Right,
say
yeah,
something
of
like
course. Yeah. We are in the stage of revising the paper, so thank you so much for the comments and questions. We will take that into account. Yeah.
So I was just, can you go back to the payoff things later on, the bar chart?
Oh,
I'm
yeah.
Sorry, where folks are, so what's your account again for extremists underbidding and moderates overbidding, and what's the dynamic?
The account is based on the average bidding data, and then we use non-parametric statistics to test that the bidding 5.77 is significantly lower than prediction of 7.
Why do you think they are doing that?
Oh, why? It's because already so if you just take 2.29 versus 5.77, they are already able to achieve much higher efficiency on the voting, meaning that bidding already generates relatively good outcomes for them. So they don't really care that much whether they get 100% efficiency or 95%. That's what's our intuition.
Okay, there's kind of satisfies saying.
Exactly.
Kind of a diminishing marginal effort for diminishing
But
marginal return.
it's particularly strange because Lois was saying people will round to 1. I mean, the moderates, their optimal strategy is always to bid 1 in theory, and they're not rounding to. I mean, they're very
Most of them are
clearly
getting
doing
2,
something
it looks
different.
like. It looks like most are doing 2. I mean, one thing that
Who knows what they're doing?
know.
It's
It'd be
nice,
nice
but it's
It would be
clearly
nice.
they're not like
It would be nice to
overwhelmingly
know if
rounding
it's
to 1.
6 people bidding 1 and then
Exactly.
Yeah,
bidding
that's
8,
right. Well, we
right?
need to look
Versus
more
everyone
into the
bidding 2.
Exactly.
detail. I mean, one thing I know is with the small group case is because sometimes the extremists in the small group free rides. So the moderates feel that they need to bid more, right? It's a best response to people to
I would just say in displaying results and relating to the comment Mike just made in the exchange, you can display without taking up a lot of physical space.
Yeah.
Just, here are all the runs. So we have like this many votes cast by moderates who are all supposed to be voting 1 according to
yeah.
The histogram.
Here's the histogram.
Yeah, that's right. Okay.
Or even in sequence too.
Yeah.
How does it change
Right.
over time and learning?
Right.
But there's a lot that, again, one can unpack to.
Yeah, that's a good suggestion.
Final question. Just one last point about the Pareto improvement and the symmetry. If it were true that for all symmetric distributions you get a Pareto improvement, then it would have to be true that you get a Pareto improvement even for a symmetric distribution, even if you throw away the rebate. Because you just grow this mass point at 0 as big as you want, and they absorb
Good point.
They absorb the entire rebate.
And that can't be true by the Maleth and Postlethwaite theorem unless there's something in the Maleth and Postlethwaite theorem which explicitly states that you can't have a symmetric distribution. I can't believe the Maleth and Postlethwaite theorem has a like non-genericity there. So that just can't be true. You're right.
Okay, thank you. Yeah, we will look into this.
Okay, let's thank JingJing.
Thank you.
for,
And thank you so much for the comments.